Evaluate the improper integral if it converges. If it diverges, explain why. All right, so I want to evaluate the integral from 1 to 4 of 1 over x minus 1 squared dx. So if I draw a little sketch of what they're asking me to do, they're trying to ask me to find the area under the curve, this is x equals 1, of x minus 1 squared from 1 to 4. So I'm looking for this area, and what makes this an improper integral is this vertical asymptote, right? It's hard to know if there's an infinite amount of area there or if it gets so tiny that it doesn't matter. So instead of going from 1 to 4, 1 is the problem because that's where the asymptote is. I'm going to go a little to the right of 1 and call that b. And I could find the area from b to 4, no problem. And then I'm going to take a limit as b approaches 1. So I'm going to integrate from b to 4 of 1 over x minus 1 squared dx, and then take the limit as b approaches 1 from the right. So this is the limit as b approaches 1 from the right of the antiderivative of 1 over x minus 1 squared is negative 1 over x minus 1. Evaluate that from b to 4. Okay, so when you plug in a 4, you get negative a third. So I'm just copying down my limit here. Okay, plug in 4, you get negative 1/3. And when you plug in b, you get negative 1 over b minus 1. And now when I take the limit, 1 over b minus 1, when b approaches 1 from the right, so imagine b being 1.1, 1.01, 1.001. When you're subtracting 1, you're getting teeny, teeny values in the denominator of this fraction. When the denominator goes to 0, the value of the fraction blows up. So this has a negative in the numerator. So this is going to go to negative infinity. So this is negative a third plus infinity, which is infinity. So this diverges. All right, so for this next one, integrate from e to infinity, 1 over x ln squared x. So I'm seeing an ln and a 1 over x, and those two functions are related by the derivative. So I'm going to use a u substitution to calculate this integral. So I'm going to let u be ln x, which means that du dx is 1 over x, which means that dx is x times du. And then I also have to do the bounds of integration on a u substitution. So u of e is the ln of e, which is 1, and u of infinity, when x goes to infinity, so does u, because ln of x is a constantly increasing function. So this becomes the integral from 1 to infinity of 1 over x times u squared times, instead of dx, I'm going to put x du, and the x's cancel. So this is the integral from 1 to infinity of u to the negative 2 du. Now the problem is the infinity, right? So how do you integrate all the way to infinity? So what I'm going to do is I'm going to integrate from 1 to b of u to the negative 2 du, and then take the limit as b approaches infinity. So we have the limit as b approaches infinity. The antiderivative of u to the negative 2 is negative 1 over u. Evaluating from 1 to b. So when you plug in a b, you get -1 over b. When you plug in a 1, you get -1. Now take the limit as b goes to infinity. This fraction, when the denominator goes to infinity, is going to go to 0. So this ends up being 0 minus -1, which is 1. So this converges to 1.